Okay, we're going to take a look at this HP3435A multimeter, and we're going to run it through some checks to see just whether or not the calibration on it is accurate and it's capable of achieving the performance I think it can. Right now we're on the 200 millivolt scale, and I have leads coming into an analogic voltage standard that I'm going to use to provide DC voltages of known amounts, and we're going to watch the steps as we go through the cal check on this meter. So 200 millivolts is 0.2 volts. If I was to go at a tenth of that, that would be 0.02. So here's the 0.01 volt range switch. Let's go ahead and try that. And we throw it online. Alright, we've got 10 millivolts, 10.0, 10.1. You're always plus or minus a digit on these things. 20, 30, 40, 50, 60, 70, 80, 90, and then we'd have to go 0.1. There's 100. Now if I go one more step, we're going to be at its range limit, 1.998, and we go to the next range, we're at 0.2, 3, 4, 5, 6, 7, 8, 9. Right. And we can go 1, 2, oops, overload. Next range. Here's 1, 2, 3 volts, 4, 5, 6, 7, 8, 9, 10. Okay. That really is the check of the DC volt range to its limit. Excuse me. If I go back down to the 200 millivolt scale and I put in 0.001, 1 millivolt, there's a mil, 2, 3, 4 millivolts, 5, 6, 7, 8, 9, 10 millivolts. So right down to the thousandth of the volt. You can't get better than that, really. Here we go to the 10,000th. 1/10 of a millivolt. 2, 3.4 millivolts, 0.5, 6, 7, 8, 9, 1 millivolt. So I guess you can get better than that. This thing will measure to the 10th of a millivolt accurately, the DC ranges. Alright, so let's take a look at an AC voltage, and what we're going to do here is we're going to reference that AC voltage with my Radio Shack, just multimeter here. See how close the two of them agree on the voltage coming out of this generator. I'll provide a signal of 60 and 600 hertz, and we'll measure the voltage on both of these units. See how they agree. Alright, we have the generator kicking out right now about 600 cycles per second. We're on the 200 millivolt range. We're getting 100 millivolts out of here right now, and my reference is getting 100.1. Well, so we're within 1/10 of a millivolt on both meters, which is interesting because it means to me they're both got to be relatively accurate. We're reading an AC voltage, which is in and of itself is a little trickier than reading the DC. If we raise this voltage, let's go ahead and put ourselves on the 2-volt range, and we'll raise this voltage. Alright, I'm getting 1 volt on the HP. I'm getting 1.004 on my Radio Shack. So we're agreeing to within 4 millivolts of an AC voltage, which is, again, very, very good. We'll kick her up one more time. Let's go ahead and take her to the next range. Let's see how far we can go. Alright, I can get 10 out of here. Alright, we're getting 10 plus or minus 1/100 of a volt. And I am reading 10.03. So I'm within 2/100 of a volt of the high side of this one, 3/100 of a volt otherwise. Again, very good response between 2 of these meters, both of them off the shelf. I suspect this HP is actually calibrated better than my Radio Shack. Okay, so we've measured our AC voltage and we know that it was accurate. We can check a different range. Go ahead and do that. 10 volts on the 200 volt range. On the 2000 volt range we're getting a reading of 9, but that's not unusual, within a digit. .9, 10, overload. Okay. So let's go ahead and check the resistance capabilities of this thing. What I'm going to do is I'm going to disconnect myself from the generator, and I'm going to reconnect to this little Heathkit resistance decade box, which provides me switch selectable 1% resistors with which to check resistance. So put ourselves on the ohm scale. Right now I have no ohms dialed in, and I'm getting a reading of 0, which so far so good, huh? Yeah, 0 plus or minus 0.01. Let's go ahead and start with 100K. Oh, instantly overload. We've got to go to the 200 range. Alright, we got 100.1. We're going to be accurate to within the 1% of scale, so my resistors are 1%ers, so I'm 100 and if I'm within 101 to 100 or 99, between 99 and 101, I'm 1%. So we are accurate here. Oops, gotta change my range. Alright, 200, 300K, 400K, 500K, 600K, 700K, 800K, 900K. And then if I was to just dial in all of the rest of these, we should hit 1 meg. Alright, 1 meg. 1,000 kiloohms, 1 meg. Okay, then let's dial back down. Alright, and I'm going to take these. Alright. Alright, we're reading 90K right now and getting a result of 91. 80K is getting 81. 71, 70K, 60K, 50K, 40K, 30K, 20K. Now this is on the 2000 range, 2000 kiloohm range. So what we're going to do, let's go ahead and make ourselves a lot more sensitive than that. We should be good to 90K, which would be within this range. So here's 90.1, 80.1. Let's forget the 0.1. I'll just read the 70K, 60K, 50K, 40K, 30K, 20, 10, 0. All right, now let's go to 1K. And if I'm going to do that, I want more sensitivity. There's 1K, 2K, 3K, 4, 5, 6, 7, 8, 9. Okay. Let's reduce our range again. We're on the 2K range, and we're going to feed in 100. So there's 0.1K, 200, 300, 400, 500, 600, 700, 800, 900. Okay. And now we're in the 200 ohm range. There's 10, 20 ohms, 30, 40, 50, 60, 70, 80, 90 ohms. And finally, let's go to the 20 ohms range. There's 1 ohm, 2 ohms, 3 ohms, 4 ohms, 5 ohms, 6 ohms, 7, 8, and 9. So we read every major significant digit exactly as we expected. And all of the others we were accurate to within 1 or 2 counts on the low win, which is very, very good response for resistance range on any multimeter. You should be able to actually resolve your resistance to the, I would think, to the 100th of an ohm. Okay, the only thing left would be current, and here I'm going to have to try and set something up, so give me a minute. Alright, what we got here, I have my bench power supply. Feeding a voltage. In series to a precision resistor that I have on this decade bank. Coming out of that decade resistor, going into the HP meter, coming out of the HP meter, and then going right back to the power supply. So, in essence, I've got a 10K resistor right now. I'm dialed into 10,000 ohms. I don't think you're going to be able to. I don't know, maybe you can, but I'm on the first position here. Let's disconnect it and I can show you. Alright, so if I go 1 click on the 10,000 ohm range, I am 10,000 ohms right now, 1 times 10,000. I have my Radio Shack meter is connected in parallel to the resistor on this bank, so I'm measuring the voltage across that resistor. I have a 10K resistor, if I feed in 1 volt, I have 0.1 milliamps. So I am essentially there's 1 volt right there. And what I am seeing, I'm on the 20 range, I'm seeing 0.1 milliamps. 0.9099, so within 1.001 milliamp of being 1 milliamp. So, and right now I am at 0.999 on the voltage, so that's probably why. And if I was to, alright, I lost the batteries in my video camera and changed them. We are in the middle of checking the current. I've got a voltage, I'm going through a known resistor right at the moment. I'm 5,000 ohms. And I'm feeding it in series, and I'm taking the series current through the meter up here and reading the current, and then taking the current back to the power supply. The voltage between the Radio Shack meter that I'm using here and the HP was different by about 0.02 of a volt earlier. So if I make an assumption that I'm 0.02 of a volt higher on the Radio Shack, excuse me, my Radio Shack reads 0.02 of a volt higher for the voltage going in, then if I compensate for that, I should be able to expect the results to be accurate on the HP. So let's try that. Right, so if I have 5,000 ohms and I was to feed in 1.02, which I am relatively close to right now, I'm 1.015. Alright, there's 1.89. I can't get finer than that. Ooh, okay, that's close enough. Then 5,000 into 1.018, and I'm getting 0.199, so 0.2 milliamps coming out, which is accurate, very accurate. For a current scale, that's very accurate. Excuse me. Okay, so if I was to change my scale up and then increase my voltage to by a factor of 10, let's do that. .02. Then what I would expect to see up here is 2 milliamps, and I'm getting 2.01. 0001, so it's perfect. I'm getting 2 MA out of here with 10 volts on a 5K resistor. If I was to reduce the resistance to 2500, excuse me, alright, so we are now, we're reading 10.03, in essence 10 volts. We have 2500 ohms selected on the resistance decade, and we're getting 3.99 milliamps, so 4 milliamps, which is exactly what I expected to get. If I was to reduce this again to 1K, I'd have 10 volts over 1K, which would be 10 milliamps, and that's as much as I can draw on these resistors here, so we're going to go ahead and do that. Alright, so I should read, I've got 10.03, I have selected 1,000 ohms, and I am reading 9.92. So I am very, very close to the expected 10 milliamps. Now, why the difference? Well, you know, I've got a 1% resistor here, so I'm only going to be accurate to within 1%. Plus, I'm using, you know, the Radio Shack to measure my voltage, which is a little bit of a handicap, but it's exceedingly close. So we're accurate on everything that we've measured so far. We're very accurate on voltage, very accurate on resistance, and very accurate on the milliamps. This is a fully functioning meter. It's a good looking meter. It has a good handle to it. Good case. Whoever gets this would be a very happy fellow, I would think, especially if he had a matching counter to go with it. Don't know what I'm talking about, but so there we go. Oh yeah, as usual, I also have a manual to go along with this meter, so it would be included.